Now here we look at the solution to question 10 of the October-November paper 2017, paper 1, variant 2. Now we are told that two blocks of masses m and the small m are joined by a thin string which passes over a frictionless pulley as shown in this diagram. The acceleration of free fall is g. We are asked to calculate the acceleration of the two blocks. Now when we look at this diagram, the first thing is to identify the forces which are acting on each mass. For example, one of the forces which is acting on this m is its own weight. So we show this with an arrow downwards. Capital M, G, its own weight. The other force that is acting on it is the tension in the string. And this string tends to pull it upwards. And then we move over to the second mass. One of the forces is of course its own weight, small mg. And of course the other one is the tension in the string. Notice that the tension in the string is the same. And one other thing, how do you show tension in a string? You show tension in the string using an arrow which is pointing away from the mass. Now the next thing is to identify the acceleration, the direction of the acceleration. Of course, it's given in this question and it is vertically downwards. That shows that since the object is accelerating, there is a resultant force on this object acting downwards. So we are going to apply the equation F is equal to ma on each of those masses. The resultant force on this big M is, of course, mg minus t. So we write mg minus t is equal to its mass times A. Now one question arises, how do I know that the resultant force is mg minus t and not t minus mg? I know this because of the direction of the acceleration. Notice that the acceleration is vertically downwards, so I conclude that mg must be larger than t for the object to accelerate downwards. When it comes to the small m here, notice that the acceleration is vertically upwards. That implies that t must be larger than small mg. So when I apply the equation F is equal to ma to the small mass, then it becomes t minus small mg is equals to small m times A. So I've got two equations here which I can solve simultaneously. And one of the methods I can use is to add the two equations downwards. When I do that, I'm going to get ma plus another ma, but notice the difference between the m's. This is capital M, this is small m, just like is given in the question. When it comes to this one, mg minus t plus t minus mg, when you add these expressions downwards, the t is eliminated and I end up with capital mg minus small m g. And of course here I can get now m minus small m into g is equal to m plus small m A. At this point, I can divide both sides by m plus m. And over here, I can have m plus m. You'll be able to see that this one cancels out with this, and it gives me the acceleration as m minus small m divided by m plus small m. Of course, g. And the best option is, of course, B. That is how B happens to be the answer to that part.